Okay, let's go over this lesson in how to set up a automatic rolling car using expressions. And to do this, we're going to go into the top view of Maya here, go into Create, pop down to Curve Tools. We're just going to use the CV Curve tool here to create a nice little sort of U shape, and immediately name this track curve. The next thing we're going to do is create a polygon cube and name this chassis mesh. And the next thing we're going to do is go into perspective view, scale this out so it looks, so at least it has kind of a more of a car chassis direction. And I actually want to scale my curve out as well a bit more because it looks a little tiny, and I want this thing to have a good sort of ride around the periphery here. When I create then my polygon torus for the wheel, it's pretty busy, and so I'm going to go to the creation of its history. Instead of 20 by 20, just knock it down to 10 by 10, and then I'm going to turn on shading, wireframe unshaded. This way I can actually kind of tell whether or not the car wheel's moving a little better than I can when it's totally smooth. The fewer ribs you have to look at, the easier it's going to be to guess this, or see its rotation rather. So I'm going to immediately group it to itself because we want to not only have the wheel rotating in one direction using an expression, we actually want the Y rotation, or the kind of differential rotation that you'd have on a car, to affect this wheel as well separately. So when we come in here and call and rename this to wheel mesh, I want to come up here and rename this to Y rotation, or Y rot group. So now when we take the wheel and rotate it up in 90 degrees to get it sort of upright, and I want to raise it up off the ground, I want to be very careful about what I'm grabbing at this point, because again, this group is meant to rotate the wheel left and right as it turns, and that's all it does. And it keeps it separate from this mesh's job, which is to actually just rotate in one direction. So if we combine them on a wheel, and then we have a rotation going in one direction, we add another rotation to it, it's going to get really messed up and really wobbly quickly. So I want to move this thing around. I want to move this wheel up over the grid, so it's kind of landing on the grid. But I do not want to do that by grabbing the mesh, because again, this is the Y rotation group. So if I grab the wheel and I move it up and out as I want, the problem is when I go back to my Y rotation for the tire, it's no longer affecting the tire, it's swinging it wide like that. So this is not the way you want to do it. You actually want to grab the Y rotation group and move it up on top of the grid and then out. And the chassis, we can sort of scale that up appropriately just a bit and move it up so that we have our little kind of monoped car. So I'm going to take the Y rotation group and the chassis mesh here and actually group them again. And this is going to be the Y rotation, sort of the car rotation group. And this is going to help us in case, for whatever reason, when I affix this car to the motion path here, if it's going the wrong direction, and we'll give this an easy way of finding out if it's going the wrong direction. But if it is in fact going the wrong direction, then what I can do is I can just reverse the car rotation group and have it point the other direction. So I would just be rotating in 180 degrees the Y, and that would be the new direction it goes. In other words, when I affix this car rotation group, you see it's going in one direction now that I've given it a little kind of pencil nose there. Under the rotation Y, I just turn it 180 degrees and it's headed the other way. So that's pretty cool. Now remember, we don't then want to take this very same group and affix it to the motion path, because then all the translation and the rotation will already have inputs coming into it. So this is just for rotation Y by our hand if we need it. So I'm going to group it one more time, and this is actually going to be the motion path top, or whatever you want to name it. whatever, if you want to say car, motion path top, whatever, it's fine. So at this point you can actually grab the motion path top and then make sure you grab one and then the track curve as your second selection, and make sure you're in the animation mode in Maya. Go over to constrain and pop down to motion path, attach to motion path. Now the minute it pops on there, it's going to fill out your entire timeline 1 through 120 on the motion path. So let's see it go. Very cool. And look, it's going the wrong direction. So now we can't rotate this. We don't want to rotate this because it's already got an input coming in. We want to go down to this first car rotation group that we made and do exactly as I said earlier, which is just turn it around 180 degrees. There we go. Now it's pointed in the right direction. And we want to make this thing, let's take a look at the animation, because we're going to want to drive this using the one bit of input it already has, which is something we just assigned, which is this motion path. So go over to Windows and pop down to Animation Editor's Graph Editor. And you can see the one input we have now is this function curve. And the values, every single one has the same value, 0 to 1. Look at the values here on the left-hand side. In the vertical column, you've got 0 and you've got 1, and that's exactly what this is. So this is no longer animated using actual Cartesian points in space. It's animated using a 0 to 1 scroll bar. So the values that we have here are not actual points in space like we've been doing when we set keyframes for things. You're basically telling this vehicle here, this node that you've assigned to the motion path, I want you at frame 1 to start on this end of the spline and go all the way over here to frame 120. And the reason these aren't points in space that are specific is you can always, even when this object is assigned to the path, continue to change the path, as I'm doing now. In fact, this is even more obvious when you come in and turn on the component editor, or sorry, you turn on the components and you begin editing them, such as I'm doing here, with using the control vertices, very much like we've done with polygonal modeling. But if you want to see things a little more clearly, since in some cases it's harder to see the components that dictate this curve, you can come up here to display and pop down to NURBS and go to not only CVs, but you can then go under display, NURBS, and then go down to hulls. And that'll show you these sort of connecting brown lines that actually really help point out the points in space that you can further manipulate the curve with. But our first and only bit of animation is 0 to 1. And that's, again, why this thing does not have specific points in space, because its animation is dictated by a beginning and an end point on a malleable spline, and there's no way to describe that with specific points in space. It just gets reduced to 0 and 1. It doesn't mean that we can't modify this. In fact, we absolutely can. So let's take a look at this from kind of a top view. If you were to come into the keyframes that dictate this 0 to 1 animation, you can continue manipulating them here in the graph editor as if they were points in space. For instance, they have these tangencies you can grab and change your curve. Right now, if we grab it, we can see it's got these tangencies, these little controllers, this sort of bow tie that flatten out each of the keyframes. So it flattens out. It goes very slow in the beginning. So it doesn't kind of starts up like a car would from a dead stop, and then goes through the animation, and then it kind of slows down here. That is what you get when you have these flattened keyframes, is the vehicle gets to that point very slowly, and then it goes out of the point very slowly. Here in the middle is actually where a majority of the motion is, because it's got the most severe angle versus sort of a horizontal flat. And if we want to actually see the changes, we can come in here, grab the curve, and change it to something that has tangencies that are linear. So if you click on this icon right here, it's got one point in space and then a line coming out of it, it will actually change this so that the animation from here on out is not smooth, and it looks a little more linear. In fact, it looks like it's kind of shot out of a tunnel, and it rounds the corner and goes and hits the end point with the exact same speed it has coming out of this, out of the mark. So these are still ways you can manipulate the animation. You can further manipulate the animation of a single keyframe here by grabbing just the keyframe and then coming over and flattening its tangency, or you can grab the keyframe and then grab its tangent controller, middle click, hold it down, and actually interactively control it as well, which is kind of cool. So in this case, it's going to reach the endpoint with a certain speed. And in the beginning, I can grab this, flatten it out. So it's going to come kind of slowly from the beginning and then hit the endpoint just full on, which is fine if you're looking for an animation of it sort of hitting a wall. But for all intents and purposes, let's just flatten these two keyframes and get back to our animation. So we have the animation here for the character, for this little car character, and we now need to change the rotation and make it rotate in, I would assume, Z. Yes, it's true. So the Z direction is what I want to manipulate, and the way that we do this is we can come up and actually grab an expression and put an expression on it for its motion according to the one animation we have, which is a 0 to 1 value. So we've seen that 0 to 1 value. We want to input that influence here on rotation Z with a certain multiplier, since 0 to 1 is not really the exact frame range we're looking for in a rotation of a wheel. If at the very end we have a rotation of 1, we're really not going to be able to tell the difference between that and 0. It's just infinitesimal almost. Yeah. So what we want to do instead is actually go to the animation and locate, well, now wait a minute, where is this being held? Where can I grab this? And furthermore, what is Maya's specific syntax looking in its name, because we need to grab that influence and put it in the description of an expression. Well, Maya does a pretty good job hiding things too. However, just like history, whenever you do a major operation to something in Maya, it tends to keep it in the history here, or rather in the input. So if you come over to inputs after grabbing the very motion path that you've, the very top of your motion path controlled car, whatever you've assigned this to, in this case it's my motion path top here, click on the input, motion path 1, and there you have the actual input that you're looking for. This is the U value. You can see by virtue of that little colored bar next to the channel that it's receiving an input. And as we scroll through this, we can actually see that number change. It goes from 0 in the beginning all the way to 1 at the end. So this is the value we want. So this is why we want to come over and go to Windows, go to Animation Editors, pop down to Expression Editor, and there's the thing we want. It's Motion Path 1 U value, which is pretty cool. But have a care, because Maya again is kind of dicey on this. It's not going to bring it up unless you actually have it sort of exposed here. Look what happens when I click off and I say, okay, motion path top, bring up the expression editor. Where did it go? It's actually giving me all the usual channels here: translate, rotate, scale, visibility, but none of the values I need, which is the motion path value, to make an expression as the thing giving the energy, giving the input. It's only going to reveal it if you come over here to motion path 1 and click on it, and suddenly there it is. So you click on that, you can go to the U value and just come in here and control C, and you can come down and actually put it in the bottom to bring up your expression and describe it all the way down to the rotation of the mesh, which I've called wheel mesh. So for me, it's going to be wheel mesh dot rotate in Z, and I can use shorthand, which is RZ, and I just create that, and this is the problem. I actually have it in the wrong direction. These should be reversed, which is we don't want to control that value. We actually want to control the wheel rotation. So this is the way it should be set up, and it accepts that. That's fine. So again, now we have the wheel just equaling 1, which we don't want. We actually want to manipulate this with a multiplier. And I'll start big, because again, this is going to be a very, we need to divide the amount of distance and the amount of a single rotation, multiply that, which I don't have and I can get, but just for now, for the purposes of this exercise, I just want to sort of eyeball it. And it doesn't look too bad. Your numbers, of course, will probably be slightly different depending on how big your car is and the distance, but it doesn't look very bad right now. And I can further prove it if I come in here and just maybe grab a couple of faces on this and just do a sweep all the way through and delete them. This is going to let me see this kind of loping donut and gauge its rotation a little better. No, it's not the number I need. So I can come in here to the second way, which is kind of a shortcut in Maya. Right click, go right to expressions. Hold down the control key and right click, and you'll see this menu pop up where the second selection is expressions. If you don't hold down the control key, you can right click on this and it gives you a totally different menu. So one of those little hidden gems in Maya, click on Rotate Z, hold down the control key, right click, and now you have the expressions menu, and it will go actually right into the expression editor, and it will grab not just the object you have, but the value, the channel that you have selected. So I can see my motion path value here. It's at 400, multiplying by 400. I'm just going to kick it up to 4,000, see if that makes a difference. Probably will. Yeah, my number lies somewhere in between, 3,000 maybe. And I can go on like this all day. And I can actually sort of do the calculation to find the length of this multiplied by the amount of rotation I need for one complete rotation and get a closer approximation. But again, I'm just kind of eyeballing it to show the correlation between these this input device. If I compromise the length of this at all, such as this twist and this turn, then I probably would have to readjust the expression. And again, I can write a more complex expression that constantly measures the length of the spline, multiplying it by how many rotations. And that would be a nice automated setup for later. So we have this. Let's make a steering mechanism that will allow us to steer the car. So if you go up here to create, let's go down to our old friend, NURBS primitives, and bring in a circle. You can actually come over and place this on the car. We should have done this when we were still building the car at 000, but no harm, no foul. So we've got this all kind of created here, and I'm even going to rotate it in the right direction, eyeballing it. Again, should have done this earlier, but this is production. So I've got grab the control vertices and just scale them in, so I got a nice little obvious bow tie with my controller. And I'm going to take this NURBS circle, and rename it steering wheel, and then group it in with the rest of the group. It is best to do this before you've affixed anything, because Maya gets really squirrely when you try to sort of modify things with inputs at the top. But I think we got off pretty easy on this one, save for the adjustments I've got here. So this rotation is going to be a 1-to-1 correlation, and I want to take the Y rotation group, and I'm going to bring this out just a bit outside the car's body. You can see it's already kind of weird because once this top path group is rotated by virtue of being attached to the spline, it kind of jacks everything up, because that's sort of the whirl direction. It's not the direction for the object itself. It should be straight ahead, but it's a good example of once you start putting a lot of influences and inputs into these things, it's not the time to rig it up in a really complex way. Luckily, we are just doing a 1-to-1 correlation. So now we can come up, and since we just want the Y rotation of Y rotate group, not the wheel mesh, you can actually click on Y, rotate Y, use our little newfound special secret handshake of holding down the control key, go into expressions, and it has the actual channel that we're looking for, and that's going to be a 1-to-1 correlation between that and the steering wheel. So steering wheel, rotate Y, shorthand, rotate Y as well. So there we go, and look at that, it completely messed it up. So let's find out why that happened. Well, it happened because I turned this 90 degrees because I didn't like how it looked from this direction. So what I could do if I do want it kind of corrected is again go back into the Y rotation group. I can go hold down Control, right click expression, come in here and actually just add 90 to it. And that's all I need. Just adding 90 will straighten it out. And now no matter which way I rotate this, it will correspond to the rotation of the wheel, including when this thing goes down the path, which is backwards, because again I've turned the whole thing 90. Can we accommodate that? A couple of ways we can fix it, sure. One of which is we can first of all we can take the value and make it negative here under the expression. The whole thing is in parentheses, so that should be pretty easy. And now it's rotating correctly. The other thing we could have done is actually gone into the Y rotate group, and instead of adding positive 90, I could have taken negative 90. Maybe that would have done it too. So a lot of different ways of straightening these out once you understand how Maya thinks, which is really the point of it. So let's create something else. Let's bring in a small locator, which is fun for rigging because you can always see it, but it never actually renders. And let's give this a particular expression that's going to be kind of cool. You can actually jump ahead in time and tell this locator to be where this car is going to be in 3 frames. Since Maya knows the whole of its motion, that shouldn't be a problem for Maya. Okay, so we want to grab the locator and go to its translation X, because we're going to actually put an expression to each of its translation channels, starting off with the translate X. And this is going to be a bit more complex. What we're going to be using here is a get attribute command, which we're going to first put into tick marks. If I say quotation, people will go and type this in, but it's actually wrong. It's the upper left hand corner of your keyboard. Underneath the escape key, under the tilde, is this little sort of tick mark that we've got. And after that, we're going to type in get attribute. Remember the camel case here. So it's get capital A, TTR, lowercase TTR. And we're going to go for an attribute of the frame. And that is, oh, sorry, not F, T for time. My apologies. And that'll be frame plus 5. And then we need to, so that's, I get the attribute in time of the current frame plus 5 more of motion path top, which is the name of my top group for the car. Translate X. So that's going to be a whole sort of equation, and I'm going to round it out with the same tick mark as I did in the beginning here. So I can create that. It now actually goes and stays with the car, only in X, of course, but it's 5 frames ahead of the car, which is kind of cool. And the best thing we can do to kind of complete it for the other locator values in translate Y and translate Z is just change this translate X, translate Y appropriately. And you can see actually the colors, lavender colors, filling them in here in the upper right hand corner. And Z, the reason that I did Y is because in case we turn this into a bit of a roller coaster, we actually still want it to match. So with those 3 values of the locator in, you can now see it in fact is 5 frames ahead throughout, which is again kind of cool. So one last thing we want to do is to have that locator follow the steering, or guide the steering wheel. So in this case, we can take the locator and then grab that which is going to sort of look at it. Is that the right way to do it? Let's find out. And then go over to constraint, and we're going to use something called an aim constraint, which means look at it. And in this case, we only want to have Y is all we really care about, and hit apply. And did we actually do the right thing and put it in the right place? Well, you can see that the sticky tape here is under the steering wheel, so it means that is being controlled by that, because that's where the tape goes, right there in that relationship. So how can we check this? Well, the best place to check it is around a very severe bend. So let's give this a nice kind of dead man's curve. by pulling out one of these points and just seeing the car around the corner. So come in close and let this ride. Now, that's not the best angle to view it in, but we can see it actually does affect the rotation of the wheel, which is kind of cool. And again, not the mesh, but the one above it. So this is being controlled, and we can also see that that value is actually changing. We might get a better effect if this was further ahead than 5 frames. So last part of this I want to do is I want to come in here to my locator, and let's say that we come up here to, just to be clever, let's come in here and add an attribute. And future, minimum, maximum 100. There we go. So we got future as a attribute now with the locator. Come in here next and go down to, you can actually go to the channel control, and let's take out some of the things that we're not going to be controlling on this particular object, just to clean it up, just to make it nice and nice and clean. There, we've only got 3 attributes which are being controlled. In fact, let's just get that out of there. Non-keyable displayed. That means it's got an influence. We don't want to mess with that influence. So, and this variable, strangely enough, is right here inside the channel of the object itself. So we want to manipulate these translation and Z to use the variable of, instead of +3 or +5 hard-coded values, use this variable as the amount of frames it's ahead in time. To do that, we can go over to animation editors and expression editor, but notice, because we've said we want to lock these out, it's not viewable. And a way to force this thing's hand is to come up here and actually grab the values and go to expression through our little special way of accessing it. And it does show. It's kind of a way of forcing Maya to just bring it up because we want to modify it. So instead of frame +5, say frame plus locator 1 future. That's it. And might as well just copy this because we're going to be pasting it a lot. Edit, and do the same thing for the translation Y. And translation Z. You should be able to see the effect because this future is currently at 0, but when we come in and grab the title of it and then come in here to the modeling window, hold down the middle mouse button, we should be able to go left or right. We can't make it negative, but we can put it up to whatever value we want. Let's say right about here at 8.2, and when we see the car hit the curve, then it's so far ahead it actually gives a nice, more severe turn to the car, which is kind of cool. Also, you didn't need to make an attribute here. You could have used an existing attribute like rotate Y that already had the ability to go forward, backward as well. You'd have a negative. Because we set this up and made it 0 to 100, I'm not able to give it a negative value, but no harm, no foul on that one. Anyway, that's a way that you can create a system by which you can further manipulate nothing more than the spline on which this little car runs, and everything else is rather automated, save for your choice of the distance with which you might want to mess with this wheel, and you can animate this as well so it doesn't get too crazy even in the turns. So that's a way to set up your own little Google automated self-driving donut car. If you have any questions, come to me. Thank you.